Hello students, welcome to analysis of indeterminate structure class. Last class we solved one problem by slope deflection method. Today we will solve another one problem by using slope deflection method. Let us consider this is the second problem, or write down example 2. Problem given by like this: analyze the continuous beam by slope deflection method, draw bending moment diagram, shear force diagram and elastic curve. And line diagram sketch is given here. You can observe the given figure. This is the continuous beam, span AB, BC and CD. The span CD is overhanging and the joint C is simply supported and joint B is roller support and joint A is hinged support. This is the given problem. Let us see how we are going to solve this type structure or this type continuous beam by using slope deflection method. Solution. Very first step is fixed end moment calculation. Considering this span AB, you can observe the load condition. Two loads are given, 2 point loads are given, 60 kilonewton and 100 kilonewton. But we don't have the formula for calculating fixed end moment for at a time 2 load on the span. But we can modify this condition. That means if we can take one by one load. That means first we can consider 60 kilonewton and after we can consider 100 kilonewton. Like this you can split, and adding both the fixed end moment, we are getting final moment of the span AB. We have the formula for calculating fixed end moment for the point load is not exactly at center. The formula is WAB square by L square. This is for span AB, but for span BA, WA square B by L square. So we can, using this fixed end moment formula, we can substitute the data. W means the given point load is 60 kilonewton and A is the length of the support A to the point load point, okay, that is 2 meter, and B is 4 meter, and the L is the total length of the span AB, that is 6 meter. Similarly, considering another one load 100 kilonewton and substitute the values and calculate by using calculator, we are getting the answer minus 67.22 kilonewton meter. I hope all of you got this answer. Next, similarly, we are going to calculate fixed end moment BA by using formula WA square B by L square. Here also you can substitute the given data and calculate the answer. You are getting 96.11 kilonewton meter. Okay, here sign convention is very important. Don't forget sign convention. For calculating fixed end moment, AB is minus, okay, and fixed end moment BA plus. Okay, you should write this sign, it is very important. Okay, next, now we calculated fixed end moment for span AB. After, next span is BC. You can observe this span BC. Here the load condition is uniformly distribution load, that means UDL is there, but it is not for full span, it is different condition. You can observe. Let us think about this, how we are going to calculate this. The UDL is acted on the span BC up to 3 meter from point C, but remaining span is free, that means 2 meter is free from any other load. So how we are going to calculate for this type span for fixed end, for calculating fixed end moment? What formula you are going to use? Think about this. Okay, let us observe here. Here UDL is given for considering span BC. You can convert this UDL to point load. Okay, you can convert this UDL to point load, or you can visualize, just visualize. If we are going to convert this UDL to point load, where it will act? Definitely it will act exact center. Center means from this span center. Okay, but definitely how we are going to calculate that distance, that we don't know. By using integration, we are easily calculate that this distance x. Here you can observe for span BC, the UDL load applying this length is 3 meter, and that UDL is given 30 Newton per meter. 30 kilonewton per meter is 30 kilonewton per meter. But for applying integration, we can take 30 dx. Okay, for converting elemental load. This distance we consider x, and this is the 5 minus x, because we don't know the exact point where it will act. So the total distance is 5 meter minus x. Okay, and for calculating this, w is the 30 dx and a is x, that means this distance is the x. You can observe the load condition, where the load is applying. On that basis we are deciding the a value. A is equal to x, b is equal to 5 minus x. Okay, 5 minus x. Next, we know the formula for calculating fixed end moment. If the point load not acting exact at center in fixed end moment, in fixed beam, so that formula you can directly use here. But here, when you are using this formula, we don't know the exact distance, so you can use the integration. You can use the integration by limits. Okay, the formula is w minus w is ab square by l square, but by using limits minus limit 2, here you can observe from where to start that UDL load. From point B it will start from 2 meter, from 2 meter to 5 meter. So the limit you can consider 2 to 5. It is clear. Next you can apply the, you can substitute the values. That means W is 30 dx and A is x and B is 5 minus x whole square divided by 5 square. That L is the total length of the span BC. Okay. You can calculate this by using calculator. Directly you can getting the answer. The answer you are getting minus 29.7 kilonewton meter. Okay. Similarly, you can calculate for fixed end moment CB. The formula is WA square B by L square is equal to integration. You can apply 2 to 5. The limit is 2 to 5. You can substitute the data and calculate the answer. You are getting 51.3 kilonewton meter. And for overhang, for calculating fixed end moment, last span is overhang span or cantilever span CD. Or convert overhang into resisting moment. That means if there is no two support, that means there is no two fixed support, then that means in case of overhanging we can consider resisting moment. Now for calculating resisting moment, directly you can take the load and perpendicular distance. That means how we are going to calculate moment CD is equal to minus 30. 30 is the given UDL load, 30 kilonewton meter, 30 kilonewton per meter. So this 30 kilonewton per meter, for here you can consider only for span C to D. Okay, C to D, the distance is 2 meter. Okay, so 30 into 2 is the total load. 30 into 2 into multiply by perpendicular distance where this load is acting at exact center. So the total distance is 2 meter. Dividing by 2 means the distance from C. Distance from C is 2 meter. 2 by 2, that means 1 meter. That means the point, if you are going to convert this UDL to point load, it will act exact center. That means from C it will be 1 meter. Okay, so that is the reason we are used minus 30 into 2 multiply by 2 by 2 is equal to, we are getting answer minus 60 kilonewton. Note down this answer. And next is the by using slope deflection equation, we are going to formulate the equation, and by using that equation we are going to calculate the theta values, that means slope values. Okay, here del is 0 because in this problem there is not mentioned any sinking value, that means settlement not mentioned. So there is, you can consider there is no sink, so del equal 0. For overhang there is no slope deflection equation. It is also very clear, you should remember, for overhang there is no slope deflection equation. Okay, next, moment AB. For calculating moment AB, we are directly using slope deflection equation, and according to that we are substituting the values. Okay, in the slope deflection equation, slope deflection equation, moment AB, you can write down every time you should write down the full equation. Here not mentioned actually, you should write down full equation. Okay, there fixed end moment AB will come here, so that here directly I substituted that value. Okay, that is minus 67.22. we already calculated fixed end moment AB is minus 67.22. you can solve this equation. You can solve this equation and give the equation number 1. Okay, and similarly for moment BA, solve means we are not the theta A and theta B is, we don't know the value, so you can simplify this equation and keep it like this in the form of theta A plus theta B. Okay, like this you can keep it and give an equation number. Okay, after for moment BA, similarly calculate moment BA and use the slope reflection equation. Here you are using we already calculated fixed end moment BA, you can directly use that value here, plus 96.11. okay, the formula is same, the formula is minus the slope reflection equation, and simplify this equation and you are getting this equation number 2. and similarly for calculate the moment BC, calculate the moment BC and simplify this equation and give the equation number 3. and similarly for moment CB, and solve this equation and simplify this equation and give equation number 4. okay, next class we will continue in the equilibrium condition. Thank you.